Hello, math analysis students. In this video, we are going to learn about the law of sines. Very important note, for this unit on triangle trig, you will need to have a graphing utility. You don't need to buy a graphing calculator. There are a lot of graphing calculator apps for your phone. Some of them are free, some of them are very inexpensive, or Desmos is always a great utility. You can go to desmos.com, or I recommend getting the Desmos app for your phone. You could do this with just a regular scientific calculator, but I really recommend using either a graphing calculator or Desmos. Whatever graphing utility you use, you need to make sure that it's in degree mode first. So everything that I do in this video, I'm going to show you how to do it on a graphing calculator and also on Desmos. The first thing I'm going to do is show you how to set your degree mode on a graphing calculator. You should already know how to do this, but let's go over it anyway. So on all the graphing calculators, they are roughly the same setup, and your degree or radian mode is up here under mode. So click on mode and then go down to radian is the default mode, so you want to make sure to select degree mode and then hit enter, and now we're in degree mode. And we could go back to our regular screen now. If we are using if you are using Desmos, then when you click on the little wrench up here, this is your settings. If you're using Virginia Desmos, the default is degrees, but otherwise it's usually radians. So you want to make sure that you are in degree mode. Always at the start of whenever you're doing anything with this unit, we're going to be using sine, cosine, tangent, our trig stuff. We always want to make sure that we are in degree mode. Okay. So we're going to be working with the law of sines today. And the law of sines can be written a couple of different ways. Sine of angle A over A is equal to sine of angle B over B equals to sine of angle C over side C. Or we can write it just the reciprocals of all of those. A over sine A equals B over sine B equals C over sine C. We're going to solve for missing sides and angles today using the law of sines. Okay, so we can use the law of sines to solve any triangle, specifically your non-right triangles. We will spend our spring semester working with right triangles. Right now we are talking about non-right triangles though. So we use the law of sines when we have information about triangles in an angle, side, angle, or side, angle order. Now that side, angle is actually going to be a separate video. So again, the law of sines says that in any triangle, this following proportion is true. A over sine A equals B over sine B equals C over sine C. This is the way that I tend to write mine, with the side over the angle, but you could also write it sine A over A equals sine B over B, or sine C over C, where A, B, and C are the sides opposite angles A, B, and C respectively. So let's explore that for just a minute. So when we're talking about A and sine A, angle A is over here, and lowercase letter a is just the side that is opposite that angle A. When we are talking about B, then the side that is opposite angle B would be denoted with lowercase b. So we have angle B, and across from that is lowercase b, and across from angle C would be side C. So angle C here and side C across from it. Very important to denote those properly. Okay, and to use the law of sines, we just need to know 3 parts of 2 of those ratios, and then we just set up the proportion and solve. Okay, so let's get into it. First, we're going to do the example where we have 2 angles and 1 side. So we want to draw a picture and use the law of sines to solve the triangle. What do we mean when we say solve the triangle? Find all of the sides and angles. There's 3 sides, there's 3 angles. We're given 3 pieces, so we want to find the other 3 pieces. I personally always like to start off by writing the things that I still need to find. In this case, we're given angle A and angle C, and we've got side A. We know that we need to find the other missing angle, which is angle B, and we need to find side B and side C. Let's draw ourselves a picture. Your picture does not need to be it does not need to be incredibly accurate. You just need to draw something to give you a reference for what is where. Now, since it says my angle A is 92 degrees, I'm going to draw something that looks roughly like a right triangle. And I'm just going to label it. It does not need to look great. A is my 92 degree angle, so here is A. That is 92 degrees. B and C doesn't really matter which one we put where. There's B, there's C. We know that A is 92, I've labeled it. We know that angle C is 36, so I'll label this over here as 36 degrees. And we know that side A is 5, so this over here is side A. That is 5. I'm going to label my other sides. Across from angle B, this is side B, and across from angle C, this is side C. So we need to find all of the missing parts. All right, since A is the one that we know about the side and the angle, we're going to start off using A and sine A. So we're going to use A over sine A equals B over sine of B. Okay, so let's fill in what we know. Okay, A is 5, and sine of A, well, A is 92 degrees. We're going to have the sine of 92 equals B over the sine of B. Well, I need to know what angle B is. Well, I can do that. Since I know that any three angles in a triangle have to add up to be 180, we can just add up our 92 and our 36, which gives us 128. And then we could subtract from 180. 180 minus 128 gives us 52 degrees. So, first thing, we said that already, angle B is 52 degrees. I can fill that in. And then I'd fill in sine of 52 degrees. Now what we have here is a proportion, and we can cross multiply these two, and multiply these two. That gives us that B times the sine of 92 is equal to 5 times the sine of 52. And then to get B by itself, we would divide by the sine of 92. And whatever we do to one side, we have to do to the other. So these cancel out, and then we have B equals 5 times the sine of 52 divided by the sine of 92. So I'm going to first go over to my graphing calculator, and I'm going to plug that in. Then I'm going to go over to Desmos and plug that in. So first, with our graphing calculator, okay, I'm going to put in 5 times the sine of 52. Make sure you close your parentheses here. 5 times the sine of 52 degrees divided by the sine of 92. And when I press enter, then I'm going to get this number, 3.942. We want to round to the nearest tenth, so that would be 3.9 for B. So B is 3.9. Okay, so we found B. B is 3.9. Now we need to find C. So let's use the part of proportion that we need. We were given A, the side and the angle, so let's stick with using A over sine A equals C over sine C. We wouldn't want to use this B right here because this is a rounded value. If we had to, we could use that, but we have more accurate values up here with what we were given, so we want to stick with using that. So plug in again. A is 5, sine of angle A is 92, and now we're looking for C over sine of angle C is 36 degrees. So again, we will cross multiply. We will have C times the sine of 92 is equal to 5 times the sine of 36. Divide by the sine of 92. This cancels out, and we have C equals 5 times the sine of 36 divided by the sine of 92. Let's go back to our calculator for that. So this time we're going to use 5 times the sine of 36, don't forget to close your parentheses, divided by the sine of 92 equals, let's round to the nearest tenth, that's about 2.9. So we have our C value is 2.9, and we have solved our triangle. We found the missing angle and the missing sides. B is 3.9 and C is 2.9. Now I solved that using the graphing calculator. Let's go over to Desmos and just see how to plug those same functions in, and we'll get the same answer. When we go over to Desmos, we want to use our keyboard, and we want to come down here to the functions. This is where we get our sine, cosine, and tangent functions. So plugging in what we had when we were finding b, we had 5 times the functions, sine of 52, close your parentheses, divided by the sine, functions, and click on sine of 92, and we get that same value, which is about 3.9. And then for our second part, when we're finding c, we had 5 times, go under functions, for sine of 36, don't forget to close your parentheses, divided by the functions for sine of 92, and we get the same value of 2.9. So whether you're using Graphing Calculator or using Desmos, we get the same values. Excellent. Okay, let's move on to our second example, where we have 2 angles and 1 side. Here we're given that our angle A is 54, B is 62, and C is 9. We could go ahead and find the third angle. These are kind of small angles, so I'm going to draw my triangle this time, making it look not quite like I did the first time. I'm going to make this one try to look a little bit more, well, it's not great. Doesn't have to be. A, B, C. We know that angle A is 54 degrees. We know that angle B is 62 degrees. We can go ahead and we can find angle C. When we add up 54 plus 62 degrees, we get 116. And when we do 180 minus 116, we get that our angle C is 64 degrees. So over here, I'm going to write the things I'm trying to find. And I already found C is 64. We're given that side C, which is across from angle C. This is 9. Across from angle B, this is side B. And across from angle A, this is side A. And making sure to use lowercase letters for the sides A, B, and C. All right, so this time we know about side C and angle C, so that's what we're going to use in both of our proportions. Does not matter which way you set it up. I am a fan of alphabetical order myself, so I'm going to, for A first, I'm going to find, excuse me, now, I forgot I wanted to leave myself a little bit of space here to write down the other things that I'm trying to find. I need to find side A and side B also. Okay, now I'm going to do A over sine A equals C over sine C. Again, you could flip this around. You could use sine A over A equals sine C over C. You could put your C on the left-hand side. Doesn't matter as long as you are consistent with the way you write your proportions. It's all good. Okay, so A is what we are trying to find over sine of angle A is 54 equals C, which is 9. Be careful when you write your 9s. Sometimes students write 9s and A's. They look very similar. And sine of angle C is 64. Okay, so again, we have a proportion. We're going to get A times the sine of 64 is equal to 9 times the sine of 54. And when we divide by the sine of 64, do that on both sides, we will get that A is equal to 9 times the sine of 54 divided by 64. I'm going to go over to my calculator and see what do I get. I put that in. That is 9 times the sine of 54, close your parentheses, divided by the sine of 64, which is this number 8.1. Now I'm going to go over to Desmos also and just show how to do that same calculation in Desmos. I'm going to clear these up. If we put in 9 times the sine of 54, close your parentheses, divided by the sine of 64, we get that number 8.1. So our A value is 8.1. And then to find our B, we will again use the side C and angle C because we knew that side C was given to us. And now we'll do B over sine B equals C over sine C. B is what we're trying to find over the sine of, well, angle B is 62 equals C, which is 9 over the sine of 64. We're going to cross multiply. We will get B times the sine of 64 equals 9 times the sine of 62. We'll divide by the sine of 64. And we have B is equal to 9 times the sine of 62 divided by the sine of 64. I'm going to go to my calculator first for that. I'm going to do 9 times the sine of 62, close my parentheses, divided by the sine of 64. And I get about 8.8. And if I go over to Desmos and check that same calculation, let's see. Oh, I could have just added that, I suppose. 9 times the sine of 62, close parentheses, divided by the sine of 64 gives us, again, that same value of 8.8. So here our B value is 8.8, and we have solved our triangle. We found all the missing pieces. We know the values of all 3 angles, and we know the values of all 3 sides. Okay, we are going to talk about the ambiguous case of the law of sines, which is the side-side angle order, in a separate video. So make sure you watch that one too.